to the LFDT community, and today we're going to get in and we're going to talk about the Fabric Operations Console wallet in the HashiCorp vault. And one of the things I'll say is I really enjoy supporting anything that comes out of the LFDT labs, and this is yet another great project that's really come to fruition here. And I want to hope that we can jump in here and go through and have a nice Q&A during the presentation. And then after the presentation wraps up, then I think we're glad to also take and have a nice Q&A after the presentation. So just kind of to give you a little background here, the Fabric Operations Console is an LFDT Labs project focused on the deployment, operation, and governance of Hyperledger Fabric-based nodes and networks, and offers a comprehensive suite of APIs and UIs designed to help the administrators efficiently manage the networks in a decentralized environment across various infrastructures. So I'm going to turn it over here to Tsvetan, and I'm going to let him go through the whole presentation with you, and I look forward to seeing your questions in the chat. So Tsvetan, over to you.
Okay, thanks, John. Thanks, David, for organizing the meeting. I'm very excited today to share our recent contribution to the Fabric Operation Console. So that's going to be the point of our session today. And I'll just, let me just jump to the next slide. So what we'll be doing, I will introduce myself a bit, and then I will go through some hands-on scenarios with Fabric Operation Console because I'm not quite sure how familiar the people on the call might be with it. So it won't take a long time. It's just to walk you through the basic features there and to the capabilities of the console. And we'll spend most of the time, of course, talking about the wallet enhancement we just contributed to the project and how it is implemented, where to find the code. And of course, I will also show a demo on the configuration and how it's being used. And we end up with some questions and answers. So about myself, John already presented myself. I've been with the community since the beginning. I remember since the first version of Fabric came up, and that's been my passion since then. Working with new technologies. I've been with the community for a long time. Did a bit of contribution, and I also one of the co-founders of Senofi, which is a company focused on software development and consulting services. So we do specialize in Hyperledger Fabric development, deployment, and operation. So let's jump to the Hyperledger console. If you have any questions, by the way, just don't hesitate to ask. And I'll be clarifying things. So I'll go a bit of more detail on the Fabric Operation Console, what it is. So essentially, the main part of it, the main purpose of that tool is to deploy, import, export, and manage Hyperledger Fabric components, and of course Hyperledger Fabric Certificate Authority. It is a web API-based service with a nice UI where you can operate those Hyperledger Fabric networks. It gives you a nice feature to manage the channels, the network itself, and do governance on the channels across multiple organizations. So that means every organization that is on the network may have their own instance of the Fabric Operation Console. They're in their own blocks, and the Fabric Operation Console allows you actually to have that governance process going on, where those consoles can talk to each other to exchange information about the network, about the certificates, and all of those assets that are required to organize and to manage the participation on a particular channel. Of course, you can also deploy Hyperledger Fabric chain code. Just mention the console supports. As I hope you already know, there are two flows of chain code deployment, V1 and V2. So the console can support both of those. And
Yep, what's
next, the next important feature, of course, it
Where
is
is it
that
located?
you could connect and work with and manage the Hyperledger Fabric Certificate Authority server. So you could register, enroll, delete users from there. And the next feature, of course, main feature is the console wallet. This is where the certificates and the crypto materials of the Hyperledger Fabric and identities are stored for the purpose, of course, to operate the network. For instance, if you want to manage a peer, you need to connect with it and have the admin to have the admin certificate to do that. So this is the wallet we actually are focusing on today, and I'll show you what it is and how the enhancement with it helps with the functionality. And last but not least, there is a set of Ansible modules and playbooks that allows you to automate any deployment and operation with the Fabric console. All of those are mainly provided and contributed initially by IBM, and the project is being actually maintained by IBM. Of course, we are trying to contribute new features there to enhance it and to help the community use and appreciate what the console can do, because it's a very, very nice tool to operate and manage Hyperledger Fabric networks. Now, if you point down there, there is a star about the deployment, the Fabric component. I'm referring to, for example, deploying a Hyperledger Fabric peers or orderers. The Fabric console is actually coupled or integrated with the Fabric operator, which is an implementation that is deployed on Kubernetes. So if you do have your Fabric nodes of Fabric components deployed on Kubernetes, the console can do that automatically for you. However, if you deploy your peers outside Kubernetes environment, let's say Docker or somewhere else, doesn't matter, then you will need to manage manually the deployment of those components. However, you can still do the operation on the network through the Fabric console by importing, exporting and importing those components in the console. So let's do a bit of a hands-on here. Let me just shift to, and I'll explain what I'm running right now. Okay, so I'm running the console right now on AWS. So it is basically a Linux machine and plain Docker containers. There is no Kubernetes behind that. So that's why there is no option, of course, to deploy the peers, the nodes from the console. But I did deploy them manually, again, on AWS machines. And I'll show you how you actually can see and operate them. So the first screen is the nodes section. Here you can see the main Fabric components, the peers, of course, certificate authorities that issue certificates for your Hyperledger Fabric components and users. So if I go on to a peer, of course, I need to associate an identity to it, which is coming from your local wallet. And I'll talk about the wallet in a minute. And by associating the proper admin, you can actually have overview, or it's very detailed view on what is on the peer right now, what channels the peer has joined, what are the installed smart contracts, and of course, some information about the peer itself, like where the API of the peer is located. That's essentially the going through the gRPC as protocol, the endpoint and the ports for as well for the operation URL. You can see the version, MSP ID, or to what MSP the peer belongs to. And there is a bit of detail here about the web proxy. It's essentially a container that does nothing but translating gRPC to a web interface. So it's just a proxy that allows the console to communicate to the peer through gRPC. So what is the next thing is the certificate authorities. So here you can see, of course, for each node you're operating, you need to have the associated user that comes from your wallet. And here you can see, of course, again, the information about where the certificate authority is located, the API, and then the operations URL. You can see the list of users, what is the type of that user, if it's a client, if it's a peer, if it's an admin. And you can actually re-enroll those identities or delete them from the certificate authority. So usually those users you see here, they're registered with the certificate authority, but mainly you would have them added to your wallet. Because like let's say it's a peer admin, so if you want to have the a peer admin to be able to operate your peer, you will need to have the private key of that admin in your wallet in order to do that. Of course, the private key of the peer belongs to the peer container where it's running, and any other admin, like let's say it's a CA admin. This is the identity that can control or admin work with the certificate authority server itself. So you can import, export those components. Importing and exporting is nothing more than a JSON file with a list of information like metadata about the component. It's essentially what is the API URL, what is the cert of the certificate authority, and everything that you would need normally to connect to the server, to the web API. Okay, so you have the channels in my network. I don't actually have any channel, and but here you can see what is the list of channels you're having. Now it depends, you know, if it's a system channel or you can have different type of channels, which is the ordering service channel. Nowadays, with the later version of Fabric, you actually don't have a system channel. Everything is an application channel that you can actually see from the peer itself. Essentially, here are the smart contracts. I talked about the smart contract, the console supporting 2.0 and 1.4 legacy version of deploying and installing smart contracts. Usually throughout the project, any projects, we do prefer to go with a 2.0 and later releases. It is just for backwards compatibility. Usually you can access the chain code through the channel page. That's how you actually trigger the deployment. And this is where the wallet is. What is important here to mention is that that wallet, so as you see here, it contains the private key and the certificate of those users. You can export the identity or remove the identity. Removing meaning it just gets deleted from the wallet, and exporting, of course, it will create a JSON file that where it will store the certificate and the private key and the name of the user. Now, Regarding the current implementation of the wallet, is that the wallet is actually sitting physically inside the browser. It is that means if you log in with the same user from another browser or another machine, you won't have those identities available to you in the wallet. So if you want to do that, first you will need to export those identities locally, then take that JSON file or a zip file if you're exporting all of the identities, send it over to another machine from where you might be operating, or to someone else, some other user that may need to operate the network. And that is a bit of a hassle here. And you could also potentially lose those identities. Let's see, you clear your browser cache and your store, or some upgrade or something happens, then you might lose those private keys. And if you lose those admin identities, you cannot operate the network anymore. So it's a bit of a risk in terms of that the console gives too much, with the current implementation, gives too much trust in the end user to manage properly the identities and the keys. So the next point is the organizations. Of course, this is if you are participant into networks, you will be importing those organizations from a JSON file that defines the organization itself, and essentially it is giving you information about where the console is, operation URLs, and API URLs. So that's more of a definition of the MSP, other MSPs, or your own, if you are managing multiple MSPs, of course. That's actually the glue or the membership service provider definition that defines the nature of your organization. You have also, the next section is the access. So the console gives you the possibility to create multiple users. You could, of course, do your own user management through OAuth2 protocol. This is what's supported by the console as well. In my case, I'm using the CouchDB as authentication method. CouchDB is a database that's being currently deployed on my machine. And if you want to do, you can actually use OAuth2 if you're interested. I won't go into details how to configure, but it's something you can do. If you download that and run it out of the box from the repository, it's going to be using CouchDB. So you can, of course, create an API key if you want to call the APIs of the console from anywhere to automate or to, for example, if you use Ansible to automate deployments and management. And through the setting, I was talking a lot about the export and import. This is where you might be using to mass export import. So for example, if you want to export your identities from your local wallet locally, you would do that export here. So by taking the identities, you could import them into another instance of the console. And of course, if you want to do the completely change the console or send some metadata to another user or whatever reason you may want to export the connection definitions and definitions of the different components like certificate authority, the ordering service, the peers, and the MSPs. And of course, you may want to import, which is again the opposite. You may deploy your peers somewhere else outside of the console. Install the console. So let's say you have a network already running. All you need to do is define those JSON files with the connection profile, bring them into the console by importing them, then, of course, import in the console wallet the identities, the admin identities of the peers and the nodes, and you may start using the console to operate and manage the network right away. So it is very flexible, fits into different environments, is not dependent on a cloud provider, which I really love, and gives you the very cool features and very let's say if you're not that technical and you're not a coder, you may learn easily to operate a network with that console. All right, so let's go back to the presentation. And I will be talking now about the HashiCorp Vault wallet. So what I'll start with, I'll talk about the motivation again, why we did that, and what we are gaining, and what how it differs from the current implementation. I'll dive a bit on the implementation itself, how it is done, and where you can find it in Git. I'll talk about how to configure that with a real example, and I will do the wallet migration. So let's say you have a console already running and you want to flip the wallet from the in-browser store-based wallet to a HashiCorp Vault-based wallet. And of course, about the next steps. So, motivation. As I explained, all right. So, as I explained, one of the challenges with the current implementation of the wallet is that you may lose the identities or the information what's stored in the wallet because it is specific to your browser store. So that means, let's say, I'll go with a new incognito window. If I, for example, change the machine, the browser, or go incognito and I log in, all right. So as you see, I can see all the peers, everything, because that model is stored in the local database of the console. So every user will have that view. But as you see, I don't have any more the identities, and the reason is because I just went incognito, so my store is clean, browser store is clean, and I don't have the identities here. Okay. Of course, if I can add those identities either by uploading a JSON file, but that means you need to have access to that JSON file physically on your local machine, or you could go through the bulk import and choose a file with your wallet identities. Okay, so I'll pick the one, I'll open it, I will import it. So as you see, it goes in here, and you actually have to reassign those identities to your peers. So that's a hassle, okay? And I'll just show you that you could actually, just to showcase how different those wallets are. So I can actually remove an identity from here, okay? And because I'm working with now 2 instances of the wallet, if I jump back to my other browser session here that is not incognito, so as you see, that wallet is intact. It's just because those are 2 different wallets now. Okay. So what came out of a couple of the projects we worked on is that we wanted to have a persistency of those wallets and have those private keys stored securely, so that we don't have to force the user to export those identities, which includes also the private keys, and send them or manage them out of band somehow. And that in some cases might be a risk for the user. So that's why the wallet implementation, and as you see that wallet that currently is in the console, it is not calling the backend. It's the console itself. It's sitting in the UI, so that means there is no web API to work with the wallet. So the wallet is entirely in the browser, defined in the browser, implemented in the browser, and there was no service in the backend to handle that. So what we had to do, and I'll jump back to the presentation. All right. So what we had to do is actually to implement as part of the console backend service with APIs, of course, new set of APIs that exposes the wallet as a backend service, so that the console UI could, instead of operating the wallet and managing the wallet inside the browser, inside the UI, it could call a web API to actually let the console backend service do the management of the identities. Okay? So what we did, we used the HashiCorp Vault, and we connect to the HashiCorp Vault through the APIs, and we actually store the identities in HashiCorp. And all the CRUD operations are implemented. So create, read, delete, everything is going through that web service with that new set of web APIs that are consumed by the console. Now, where you can find that code, it is very straightforward. I'll just show you the Hyperledger Fabric Git, Hyperledger Operation Console Git. So have in mind that is under the experimental branch. Because it's very how to say, it's a totally new enhancement, new feature in the console. We had a bit of discussion with the community and the current maintainers. So we decided to leave that feature for a while in its own branch. So we may reduce and let the community use it, and reduce the risk of breaking something in the official release of the repository of the project. So essentially, so the first thing have in mind is the experimental. We will be merging that, hopefully, depending on the feedback, and see how that goes in terms of stability and maintenance. So the source code, essentially, it's very easy. It's well abstracted into a Vault client if you're interested to go through the code and to understand how it works. But it's very much pretty much straightforward implementation. So you have all the wallet implementations, all the wallet implementation methods implemented, like list, like get the metadata, delete, and read, and update. So this is where the code is of the backend service, and in the front end, it's a slight change. So you can actually also take a look at it in the Powell package here if you're interested. So the change, of course, you can see from the repository commits to understand what's being changed and touched there to implement that feature. Okay. Now, the interesting thing here is also how to configure. You can go through the documentation section of the repository. So we added a whole section to explain in details how that works and how it can be configured. So all you'll need is, of course, a HashiCorp Vault, an access to it with the user and password, a config file that you need to provide to the console. And that's essentially things like username, password, and the path to the secret engine. And of course, accordingly, properly configured Vault, where you will be storing the identity, certs, and private. So how you actually configure that, if you are interested in details about how to configure HashiCorp Vault, I'll show you just an example right now, but you can navigate to the documentation to see what you need to do to enable a secret engine user, create a user password, authentication methods, and policies, of course, to access paths or resource in HashiCorp Vault. Right? So what is the configuration? So let's start first from the Vault. Okay? So usually what you do in Vault, you create a secret engine. This is where it starts. Of course, if you may reuse an existing engine, but most of the cases it will be a new deployment. So it is always preferred if you are using the same instance of the Vault in your environment to manage other resources, you need to create, of course, a new engine either ways. If you're using a new Vault, you need to create a new engine. Anyways, so you just enable a new engine, you give it a name, you select it's a key value store engine. So you give it a name, something, whatever, and you enable the engine. Okay, so I already create one. Just close that and named it KVP. There is nothing more about the engine itself. It's just a location or place where um, the backend service, HashiCorp Vault enhancement of the console will create the secrets. And as you see, the secret data is actually there. It's very straightforward. You have a path to the secret, and I'll show you how that path gets created once you import or create an identity inside your wallet. And then the secret data itself. So you can do something like cert, which is the key, and then you do the cert itself. So you can add a new one, and you say it's a key, like a private key or something. We will take a look at that in a second. And you need to provide the private key. So this is how the console is gonna store the identities of the wallet inside Vault. Usually you don't really touch anything manually in Vault other than the configuration itself. For example, you may do import of identities from directly into Vault from other places, or you can do it from the console, which will import identities inside the Vault automatically for you. Right. So for the user, you need to define authentication method, which is user pass. So for example, if I go and say, because we need to connect to Vault, I can say I want to create a new authentication method. A username and password is the one to choose. You give it a name. And after you have the authentication method, you can create a user. Make a specific user for the console. Don't provide a user, of course, that's not a good practice. That is used by someone else. So think about it as a technical user to be used only by the console. Of course, you may have scripts or automation that creates and generates password and creates all of those files, so no one gets real access to the password. But that's more of a deployment topic. And for the user, of course, you need to provide a proper policy. So I'll go to the user, and you need to assign a policy that where you need to give that user a path, which is your engine secrets engine path, and you provide what that user can do, like create, read, update, patch, delete, list. So if you want to have your user in the console just read, create secrets, you may actually remove, for example, the delete functionality at the Vault level itself. So the user in the console won't be able to delete the secret if you want to keep those forever in your Vault. Okay, so those are essentially the main things. So enable a secret engine, a policy, and a user assigned with to a particular authentication method, which is user and pass. Okay. So that's the very basic configuration of Vault. So the next thing is, of course, to provide the console a means of how to connect to Vault. So for that purpose, the console needs to have access on locally to a vault-config.json file, and you need to configure that. Okay, so when you deploy your console, make sure that whenever you deploy that, make sure that the console has a path to that vault config JSON. And I'll show you what it is inside. It's very straightforward file. So what I did here, I'm using Docker Compose. So I'm just doing a mapping from the vault config to the internal path into the container of the console. But that's the path you're looking at. Okay? So this is where you want to map to your vault config. So what's inside the vault config? So as you see, it's essentially what I just configured. You need to do the vault engine path. You need to do the authentication method path I just showed you. You need to do the URL where the vault is located. In my case, it's running inside the container, so on the same kind of logical network of the Docker Compose is doing, and it is accessible through the vault at port 8200. That's the API port. That's not the UI port of the vault. And of course, username and password. So it's on my local host. It's not an issue at all. You see it test. It's fine. And then the API version is v1. Kind of hard-coded thing, and you have the vault path where that is actually the root path under below your secret engine where the identities will be stored. Okay, you define it essentially. Now, now that's about the configuration. All right, so I just show you that that's the old console, and now I'm running a console instance on my local machine, and it's empty. Okay, so it's a bare console without any resources inside. So usually, what I would do if I want to deploy, like import a component from outside, I could generate those JSON file myself. But another thing is to export everything from the one console and import it into the other. So I can pick to export everything, and it will essentially, I already did that. So it will export it into a zip file that contains things like let's say if you want to take a look at the wallet, I'll open it so you can see here the private and key and the cert. And you, for example, have the the peer, which is looking like that. So it's where the peer is, what are the root certs. There is nothing private here. So the only sensitive information is inside the wallet. Of course, that's the private key, but also are all certs and endpoints that point to where your peer is. Okay? MSPs, IDs, and all that. So this is your what those files look like. So the same for certificate authority and organization. So what I'm gonna do right now, I will import that file. So it will essentially import everything, including the wallet content. Okay, so I'll open it and I will import. Okay, so now my console on the local host have access to have all the nodes imported, and as you see, because I imported the wallet, it automatically assigned my peer admin to the correct peer, and I can actually operate that peer right now from a completely different console. Of course, that's a different. That is the same peers. I did not deploy new network. I just exported, and imported the data of the network and the peer, the Hyperledger Fabric components into my console running on my local host. Now, what is here interesting is that because that console is connected to the wallet, now those identities, they don't get stored in the browser anymore. Okay, and indeed, if I do another session, all right, so I can have access to the same wallet. So that wallet right now is actually persisted inside Vault. Oh, and indeed, if I go back to the Vault and I take a look at the how I'm token secret. Just a second. Let me just log into Vault in my root token running locally. Yeah, so it's a refresh issue. So as you see, FOC was the path where I did define in my Vault config JSON for the console to use. So if I go inside, you see that every one of those identities, they have their own path. And inside um, the secret, you can see different keys like CA root certs. That is actually the root cert of the certificate authority. You can see the data, which is essentially that is the certificate, that is the identity information itself, like what is the certificate of the peer and what is the private. So this is where your real crypto will be stored. The other is just metadata, meaning who's the root certificate authority who issued that certificate, and what are the peers. So if that entity manages at peers as admin entity, here is, for example, a list of orders, peers, what is the ID of the identity, and all of that information. So usually you will be able to see all of those. So for example, that's my peer admin, and you have the cert here of the root certificate authority that issued the certificate. Again, the ID and the private, which contains the credential, the certificate, and the private key, and of course, what peer this identity manages. That allows you to actually, by importing, exporting, to automatically essentially assign identities to particular components that you already manage inside your console. Right? Good. So all of my three identities are here. So if you're about to use that new feature, and let's say you do have your own console up and running, you may want to um, upgrade to the new one. But in order not to lose your identities, if you want to move from the in-browser store managed um, wallet to HashiCorp Vault managed wallet, so what you would do as steps to migrate is, first of all, to export your wallet manually on your machine through the bulk data management export of your existing console. So of course, in that case, I would need the rest. Okay, so now I have my wallet exported locally. Then you need to upgrade your console with the proper Vault configuration. So you need to, of course, prepare your Vault and then do the Vault config properly. Is that file provided to the console? Upgrade the image of the console so it actually can use the new implementation, and restart your console. So after the restart, of course, because there is no in-browser store, a wallet store used anymore. Your wallet will be empty, and in order to repopulate it with the entities, with the um, um, identities you already had, what you need to do is to import the file you exported at the first step of the process. So essentially, that is the migration steps to do if you want to use the new feature, the new kind of wallet type of wallet in Fabric Operation Console in your environment with minimal downtime. And of course, if you want to revert back to the in browser or in store implementation, you could do exactly the same steps. Export, and then restart with the other image, and that contains the old implementation, or just remove the vault config from the path. So essentially, what's going to happen is that if the console does not have the vault config configured locally, it will revert and use the old implementation, the existing implementation that stores the identities into the browser-based wallet. Okay. Okay. So that was deploy and export. So I have at the end of that slide, I have a couple of links that might be useful for you. And I would say let's see if someone has any question or
Yeah. Go ahead, Arthur. And then we have some questions in the chat as well. So Arthur, go ahead and just go first here.
No, później będzie.
What is your question, Arthur? Okay, we can't hear you right now, so I'm just going to go ahead and put you back on mute, and then let's move on to the questions that are in the chat. Okay, the first one we had was, can we import IDs from Entra ID?
Can you repeat that? Make sure I understand it properly.
Saw, if you want to come off mute and ask the question, that'd be great. I don't know if Saw is still on here. Doesn't look like it right now. Let's move on then to Themba's question. Is Hyperledger Fabric blockchain reconfiguration possible for system reinforcement and evolution? And the basis for his question is based on the trend that some tokens and cryptocurrencies fail or wiped out in the medium term. So in the long run, infrastructure upgrade might be needed, including code updates.
Well, I would say that's probably a different topic. It's more of a generic topic about the Hyperledger Fabric itself. Now, regarding that's, if I get the question right, it's more about the upgrade of Hyperledger Fabric network or networks that are already operational and running. So all of that upgrade, of course, that is possible if you want to change the infrastructure. Like, let's say you want to do upgrade the CPUs if your use case requires, like, let's say, smart contracts, or even if you have users, increasing number of users, you may want to first of all understand where that upgrade in question is coming from. Is it a question about upgrading your infrastructure or the hardware where your peer is running, or is it about the ordering service, or it's about the application that is being provided to your to the end users, right? So depending on that, you may spawn actually multiple peers, for example. That's one way of doing it, and increase the capacity of your hardware, of your infrastructure, join new peers there, and decommission other peers. And of course, if you use Kubernetes or something else, it's about increasing the resources that are available to your Kubernetes cluster to achieve that bump in the performance.
Okay, and then there's a follow-on question. Does review happen on metadata, code, and development happen to assess and make corrections on probable system failures that result in token or cryptocurrency failures?
That's again not that much relevant to what we're talking about. It is something probably that might be related to the Fabric token, which is a completely different topic. So I can't tell much about that, unfortunately. If someone on the call may have an idea how that might be answered, go ahead.
Yeah, no problem.
Okay.
Anybody else want to come off mute and ask a specific question? And I guess I'll maybe see Dave. I see you're on the call. Do you have any questions that you'd like to ask about the presentation here on the Fabric Operation Console?
Sure, I'll ask one. So would you typically recommend to run the HashiCorp Vault in the same cluster as the console or somewhere else? Does it matter?
I would say no. So essentially, it is like that. Either you have already Vault in your environment. It is highly likely. It could be also a service that's been used. HashiCorp is a service managed by someone else, because managing the HashiCorp Vault, it's if you want to do it by the book and make sure everything is up and running, and all the distribution of the nodes, all robustness, high availability is in place, then it's an exercise by its own, nothing to do with Fabric or the console. So essentially, what we do, if there is no Vault running inside the environment, or maybe there is one, such scenario also exists, and people just use it for a particular application. They don't want to share it with some other application for security reasons or whatnot, and then you may want to deploy another HashiCorp Vault. Essentially, we usually do that by deploying it onto a dedicated cluster, a Kubernetes cluster. And that might be or might not be the same. Of course, you could. It comes with the overhead. If it's a dedicated Kubernetes cluster, it makes sense if it's used by multiple application. If it's used just by Fabric CA, then you can deploy the console. You can deploy the peers and everything inside the same Kubernetes cluster, and make sure you have enough nodes to avoid downtimes. If something goes wrong on a node, if you need to do staging or upgrades and all of that. So essentially, in one of our projects, we run all of those basic components inside the same cluster, and of course, the console goes together with on the same cluster. It's just because the console, when it runs in Kubernetes cluster, it allows you to actually initiate the deployment of peers. So as you see, there is no button here saying deploy peer, and the reason is because it's running in Docker. But if I run that console in Kubernetes, I will be able to deploy the peer from here, and the console will deploy, of course, the peer on the Kubernetes cluster where it is running. Okay. So again, depend on the use case, David. That's my answer. If it's dedicated to the console, go ahead. And you want to manage it, go ahead and deploy it in the same cluster. If it's used and shared by other components or other applications in your environment, you need probably a dedicated place to run it or even use it as a service.
Okay, perfect. Does anyone else have any questions specifically about the presentation today? If not, I'm going to ask a question myself. Let's see if we do. Okay, so the main question I had for you is, now that we have this in the labs, what is the plan for graduating the project from the labs into, full production LFDT project? And really maybe talk about the roadmap coming ahead.
Yeah, there's probably a long way. So the situation right now is that we are trying to kind of start doing more and more. There are other features that the console, is good to have in the console. So it requires additional contributions, and of course maintenance is important part of it. Now, what it takes to get to graduate that project. For me, the console it's a very good shape. It's again it's the same source code, or mainly the same source code, of course, stripped down a bit. That's been initially contributed by IBM, so that's been well tested and proven to work well. I had no problem with that. So maybe David can comment what it takes to graduate, but to me, it's a logical step to go forward with that. And maybe another thing that is also kind of a challenge here is to promote the console to the community, so we can have more people, jumping in, trying it out, see the benefits, and all of that. It simplifies many things around Fabric. And again, it's very independent and open to deployments anywhere. So it's a tool that to me deserves to go as it's a graduated project. So David, can you say more things about what's actually needed from your point of view?
Sure, and sorry that I haven't been. I was on another call until I just jumped on just in time to hear you say my name. So sorry, what was the question? Like, how do you take a lab and turn it into a project?
Exactly, yeah.
Great. I'll get a link, but there is a process for this, and it's happened several times. There are several other projects that have gone from a lab into a project. So, for example, Firefly, Cacti, Solang. I mean, it's a pretty established process. And here I'm going to drop a link in the Zoom chat. This is to, wait, excuse me. This is to the lifecycle document that talks about how do you go from one stage to another. And it's basically just a matter of submitting a proposal to the TAC. The TAC is the technical governing body in the community that makes decisions about things such as what projects to accept. And so you basically send them a proposal. You describe what the project is that you're proposing. In this case, you could point to a lab. I think it definitely helps to have a lab so that people can see, hey, this is not just something in theory. This is an actual community. This is something that has a history to it. So you would point to the lab and you would explain why you think it's ready to go to the next stage, and then they vote on it, and then that's done. So it's a pretty straightforward process. And again, if you want to find out more, you can go to the governing document there. But that's the short answer. And if you want kind of a deeper dive into that, Tsvetan, you and I can have a call and we could walk through. I could show you some existing proposals that have come into the TAC in the past, and you can look at those as a model. And those are all public. You can go and see what's been proposed in the past. But that's the short answer.
Okay.
And this is Dave Enyard. I'll give a more nuanced answer. So this is a lab that's associated with a project, and specifically Hyperledger Fabric. And in those cases, the TAC usually defers to the maintainers of the project that it's associated with for them to decide whether this repository would be stay as a lab or elevated to kind of an official sub-project repository within Hyperledger Fabric. And what the Fabric maintainers have thought so far, whether it's right or wrong, is that we've kept the deployment related repositories as labs because for core Fabric we wanted to keep the maintainership and the support for Fabric to be kind of generic across deployments, and we didn't want to say like dictate you should deploy it this way or you should deploy it that way. And we wanted to make sure that all the deployments kind of had a level footing. So for that reason, we've kept all the kind of deployment-oriented repositories as labs. I'm not saying that's the right decision or that'll always be this decision, but that's what we've concluded and thought so far.
Okay, everyone. Well, we're at the top of the hour, and I appreciate everyone joining this nice discussion this morning. Please feel free to follow up with Stephen and Dave around this project. And if you have more questions, join in the Discord community, and we'll look forward to connecting with you on the next meetup.
Of course. Thank you. Thank you, everyone.
Yep. Have a great day.
Okay. Yeah. Bye.
Thank you. Bye.